Hello everyone, I would like to introduce our project. Our topic is research on distributed evolved packet core network. Let's take a brief review in the EPC. The EPC is the 4G core network in a communication system. The traditional core network is a device that is equipped with the software and hardware. The figure shows a typical components in a 4G core network. Recently, with the revolution of cloud computing, more and more operators and suppliers are deploying the EPC as an IaaS to cloud. So we want to explore more on this topic. We decided to use the Nest EPC, an open source EPC implement, but it did not upgrade for a long time and did not provide a distributed service by itself. But in our research, we found that NestEPC used a back-end database MongoDB, which made it possible to be distributed. That made all the service distribute, so we take some efforts on it. We first implement a replica set in MongoDB and take some performance tests and scale tests on it. After that, we modify NestEPC code that made it work in the FreeBSD and Ubuntu as well as the Gentoo. This is the system modeling. We use the load balance to handle the traffic from the NestEPC to the MongoDB. As shown in the figure, we plan the Hyper-V host and NestEPC to the same communication subnet. The network is VLAN isolated by core switch, and the access to the internet will through the firewall NAT and policy control. At the same time, we create a virtual subnet for EPC terminals, which will access the communication subnet of NestEPC through the SNAT gateway established in NestEPC named PGW10 and access to the internet through the default route. Now let's implement the scale test for MongoDB clusters. We first log in the primary node and the secondary node. As we can see from the screen, the secondary node is the ID 1 and the primary node is the ID 0. And then we implement the power off, means shut down the primary node. After for a while, we can observe the ID1 secondary node will become the primary node. After that, we turn on the original primary node. As we can see, when the original primary node power on, it will not become the primary node at the beginning. After for a while, it became the primary node. In this part, we will introduce how we implement the performance test for MongoDB. We use the YCSB script for the latency and throughput test. We set up 5 different space instances for our testing and run the YCSB for synchronized and asynchronized. We tested the run throughput, load throughput, and the read latency, insert latency, and update latency respectively. Here we show how we use the script for the performance testing. Here's the MongoDB performance testing result, which makes sense because the performance increases when the space becomes larger, and the cluster will result in lower performance and bigger latency for network communication. Finally, we show how we build the NestEPC from our source code. We still have some future work to finish, such as we have to simulate the real SIM card and have the smartphone and antennas 4G base stations to test. That's all, thank you.